Very good evening to all. Welcome to the fifth day of sessions. And in this session, we will be discuss about the nanodical softwares and silicon PN junctions or transistor type of device. So if anybody more want to join, so please inform us and they can join. In our previous session, we have already discussed about the rescue softwares and now it is a fifth day of the sessions. We have already created one type of device and band structures, transmissions, VI curves, and density of state, different properties we have calculated in our previous sessions. Now we are going to discuss about the silicon PN junctions and transistor type device, how we can do dopings or any things that we want to study in here. So you can ask in between anytimes. And now I'm going to start our session. We have already discussed about their device studio and about their tabs, how we can import material and how we can do analysis, how we can create XCF files. So we will directly go with the file options and imports one of the materials because we are going to create in here the device. After that, we created another property. Firstly, we will be create transistors. Please click at the file options, then move toward the imports, import locals. You can see we have 0D materials, 1D materials, 2D materials, 3D materials, and organic materials. You can create any type of device if they exist, and otherwise you can directly import that different type of formats. We will be follow one of the examples. So how we can create the transistor, I will show you in this session. Like in here, you can see 0D materials and molecules, amorphous and crystalline. Same for the nanotube. Who want to see in here, you can see. And 2D novelty materials, graphene, 3D material like conductor, insulator, layer materials, like you can see. So number of the 0D materials, 1D materials, 2D materials are present. Firstly, we need to import one of that conductors. Like we are simply imports one of that pure metals. You can import any one of the metals because first we need to create the same electrode like left electrode, right electrode, and then one of the scattering regions and move toward the device structures. You can import simple AG. Please follow that step one by one. We have already created that type of device in our previous sessions. So simply you can also import AG file. Please follow that step one by one. After that, you need to click build option, redefine crystal. You can choose for body center, click in the preview, face centers, click in the preview. It is a user defined options. So you can choose any one of that. Please click at the face center and preview. Like this structures you can see in our screen. And then please click at the build tab. Please follow that step one by one. I hope everyone have completed this step. Now you need to create in here the supercells type of structures. You can increase and move toward the redefined crystal. You can see the redefined crystal by pressing the new cell vectors and linear combination of the current cell vectors. You can choose any one of these things like this and click at the preview, like check. If you increase the large direction as toward the C, so create a different structures. It is a supercells, one of these. And if you increase the number of the atoms, so it will take too much time. I'm considering simple with two direction at A, two direction for the B, and in here you can select 4 and click at the preview. Please follow that steps. And build. You can see in here the different tab. Simple click at that 3D viewer and please click at the XY view. So you can see the A, B, C will change according to this. Now you can see. Please go with that 3D viewer tab and XY. Then you can see that type of structure. Okay. Now you can again select that portions like this and please click that delete tab. Same, you need to select that and click delete tab. Hold the mouse and then select that top side and that side and click in here the delete tab. And you can see that type of structures in your screen. One minute, please wait. If you have completed this step, now I'm going to move ahead. And again, you can move toward the 3D viewer tab and please click at the ZX view. Balipalli Chandrababu sir is asking, sir, once again explain this. Okay. At the top side, you can see you need to import local 3D materials, and in the conductor, you need to import one of the AG, and then again move toward the build tab, redefine crystals, select the face center, then like this, and click the preview and then build. It is a second step for this. And after that, again move toward the build, redefine, and select 2 at the B direction and the C direction, and click the preview like this, and then build. It is a third step, and fourth step. After that, you need to select that portions XY view, and then you can move toward the ZX view. I hope everyone have completed these steps. Please select that tab, that items, sorry. Please select that items. Again, click at the delete. Then select that topmost. Please click that delete. Again, select that. Click at the delete. We have already created that type of structure in our previous sessions. For your simplicity, we have chosen that. Please follow that step. Next step, please select that. You can move toward the convert to crystal tab and take that value 20. It is a user defined value for change your structure at the crystal form and create the vacuum in here 20. For the vector B, A, B 2020, and it is automatically selected at the C. Please choose that value. It is a previous lattice, you can see. You can also define by your own selves, and otherwise you can simply choose simples, face center, body center, rhombohedral, different structures are given. So you can also create by your own selves, but if you want to define with system, you can move toward that type of structure, and for the user define, you can choose your value. Sandeep Agnihotri asking, sir, it is a convert to crystal, sir. That tab, convert to crystal. Please select that value 20. 20, and it is automatic selector 16.3428. Please choose that value and click the build. I hope everyone has completed these steps. Then please select these atoms and click the mirror atom option. And we have already selected XY view. Select the direction like this and apply. Please follow that. Select mirror atom, XY view, and direction you can choose 6 and copy and apply. Please follow that step. And then please click at the apply. Now you can select that tab and click the convert to crystal. Select in here the 39 and then please click the build. You need to change the direction or the Z direction because you need to also move toward that directions. Click the build like this. Please follow that step. Convert to crystal. Sorry, it's converted to device. Convert to crystal 2020 and you can select in here that value 39. After the complete of this step, you can move toward the center along A direction and center along B. Please follow that for A and B and C. We are created in here the mirror symmetry because if you going to create again that structure, it will take times and sometime it will be select a wrong value. Therefore, we have that mirror atom options. You can create same to same structure in a single minute. Therefore, I choose that option.
Hello, sir. There is no screen visible.
Uh, my screen is not visible.
Yes.
1 minute. No, I hope it is a visual. Please check your network and again reconnect it, sir.
Okay. 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 Sir. Thank you. Yes. Now visible. Now.
Okay.
Thank you.
Please follow that step. If someone want to ask in between and they left out, so please ask. And otherwise, I'm going to move ahead.
So please repeat this step again.
Okay. Like if you have selected that options for the mirror atoms, you need to move toward the convert to crystal form. We have in the previous we have selected in here the 16.34 like this value. Now you need to select in there 39 value, and then please click the build. Then it will come at the single cell like vacuum type of structure and crystal form that you can get. Only move toward the convert to crystal and change the value 39. So in here you can see one of that AG and one of the AG that have created, like we can take as the left and right electrode type of structures in here, but we need to one of the central scattering regions or central materials. So we can create another one of the materials like in our previous session we have imported biphenyls, and but in here we can also create. It totally depends on the user if they want to choose another materials or want to create different device or different things, so they can choose. Otherwise you can follow the same, like import locals. We have different molecules or materials, you can see, but we just created one of the device structure with small atoms, like we can choose the graphene. So please import graphene file, import local, and in the 2D material you can see that graphene material, and please import that material. When you imported that graphene, then you can move toward the build tab, and the same steps you can redefine that crystal. Like if you chooses that value, you can see, but if you chooses that, so in here you can create the supercell type of structure, but at the simple examples you can choose that value like this 2 2 2 6 graphene atoms we have selected in here. So please choose that value, redefine crystal, and select that value. It is a procedure for created one of the device. You can create number of the device by choosing that type of parameters, that type of value. So it totally depend on the user. So I'm just considering one of the example. Once again, I'm telling you. Click the preview and then please click at the build tab. Sorry, is asking, please repeat. Okay. You need to import firstly graphene materials from import tab, import local, and 2D materials, graphene you can select and please click that open. After selection of that graphene, you can move toward the build tab, redefine crystals, and select in here that value 33. You can check in here the preview like this 1 3 at the B direction for 3, and it will be same. It totally depends on the user. If they want to change face center, body center, or anything according to your device, they can choose and click the preview and then click the build. Please select that value and follow that step, and after click at the build tab. Okay. When you redefine that, then please select that value, sorry, select that atom and click again in that AG redefine and paste that graphene. Okay, please select and then click that tab, and like this you can click. You can see here that structure of the graphene redefined are coming here, you can see, and click that center tab like this. Please follow that step. Select Control and C and click in here and Control V. Paste in here your structure and then click the center tab. Follow that step.
So center tab is not working in my case. I just take and copy and paste.
Sir, center tab is that options.
Okay.
Okay.
So I have just taking the copy from the graphene.
Please copy that structure and then
Okay.
click in here and then paste your structures. After that,
Okay.
you need to select that and then you please click that center tab. You need to
Okay.
select that. Okay. When you selected that,
Yes, sir.
okay. Now you need to create the bond between that AG and AG, and in between the scattering region, you can select any type of material, molecule or anything, and any type of elements or materials. It totally depends on the user, but you need to create in here the bond like in the previous session. So same as use that move atom tab, rotate atom tab like this, and move atom tab. Transitional log XYZ, you need to select in here the screen view. Please select the transitional along screen view like this, and it will be same. You can choose in here the 15 angles and it will be easy. It totally depend on you, sir. You need to arrange and create the bond between this atom and these atoms. So it will make one of the device. You need to check distance between these, like we have zoom more, you can see. You need to create between these atom and this, arrange like this screen view, and please select that. And you can see in here two bonds are created. So again, we undo redo option, select that atom, move on again like this, again select, like this. Let's make easy for you. 1 minute. It will take time. So like in the previous session, you can also add one of that atom in between, so it will easy. So you can make device. 1 minute. Click the add atom. Select one of the nitrogen. Okay. Please click like this. Follow that steps. You can undo redo and click that add atom. Add one of the nitrogen, so you can make easy bond. You can easily make bonds, and otherwise it will be difficult. And again, you can click that add atom, and same you can click and create like bond like this. Please follow that steps. It one of the scattering regions materials. We have selected Ag, nitrogen, and carbon chain. Again nitrogen and one of the Ag materials structure. Now you need to create bonds in between. It may be a sometime taking time, but you need to use your tab like move atom and rotate atom. You need to select in here the screen view because we are only connecting here the bond, not change any parameters. Not we are changing any parameter in here. That atom you have selected, only they will move like this. Simran Patras are asking, I'm asking why you put nitrogen atom between the carbon and silver. Ma'am, you can, if you don't want to select that nitrogen, you can remove that nitrogen. Do I have attached here because it will be easy to make bonds. So if you connect with the Ag or Cu and that material, you can also choose that. We just select one of the scattering regions. Therefore, we have select nitrogens. That nothing means. I'm just going to show how we can create device. Please follow that screen view and try to create that bond.
Sir, nitrogen atom cannot connect with this graphene atoms because I will try. I have tried
Uh,
already, but not
uh,
able to connect.
Sir, therefore I'm telling you, if you move like this, 1 minute, you can see distance between that atoms like carbon and nitrogen. If you see large distance, so they will not connect. First, you need to come with these less distance. Like you can use that tab, move atom tab and rotation tab. For
Okay,
move,
okay,
uh, like you can choose
okay,
that rotation and move atom tab and then try to connect these bonds like this. You can choose that of screen view. You can use that tabs. It
okay,
will
okay, fine, sir.
some. Uh, It may be some difficult, but if you want to create device, so you need to use that tab. Therefore, I'm taking too much time in here, so you can use that. You can use that Android tabs and why not connect directly the silver atom? Ma'am, you can do. It will also create one of the device structure. If you want to create that bond between this, you can also create. You can't add nitrogen. It's not necessary. You can directly connect with this. It may be scattering regions like central region, and it is one of the electrode regions can be. Yeah, okay. Please try this and verify if they completed, so we can move forward. If you can see that tab, if you are selected like this structure, and then if you move like this, they will rotate in down direction. At the z direction, you move back. Distance you can see 0.1. If you're selected in a long distance, so they will move more like this. If you select a small distance, they will move small and small distance. So it's just for the movements, and it's just angle considering in further rotation. Gopal Krishnan sir asking what is kind of using or advantage of nitrogen atom in between silver and graphene. Sir, it's just to create the one easy bonds. It will take not too much time. If you want to remove like this, you can also remove. It doesn't much needed. You can directly connect with these bonds. We have already told, sir. I'm just a simple considering one of the nitrogen, so not to move much distance in between. Just simple, if you select it, they will create. It's just one of the example portion to create one of the device. And otherwise, it will take too much time. So I hope everyone have completed this step and they created bond in here using that in recalculate linker bonds. And click the ZX view. PK Patnaik sir is asking what is the application of this structure. Sir, I'm not able to understand. We are just created one of the device structure. We are not belonging in there in here the theory parts. We just showing one of the device structures, how we can use that materials and how we can create left electrode scattering regions or another materials. For the theory parts, you can work better like if you want to create bifinite molecular structure or aluminum like structure, so you can choose. We are just create one of the simple device structures choosing random materials. uh, Naglingam sir asking how to connect the bond. So use that arrow tabs. You can see drop down. You can use that recalculate wrinkle bond of tab. In my screen, you can see. Use that in the corner. You can see. Gopal Krishnan sir asking PN junction diode and transistor design. Can I get PDF for it, sir? We will provide to you. We will provide, sir. So now I'm going to move ahead. Like you have created that type of device structure, you can click the center tabs. Convert to device. Please select that convert to device and then choose left electrode, right electrode. Click the preview. Now you can see that region. If you want to increase in here that value, you can choose. Click the preview and then build. Please follow that step. You can see. I hope everyone completed these steps. Now, if you want to increase the scattering regions, you can choose that add buffer options like this. You can select 2.04 to 2.0 it for only the increase in between the scattering regions like this. You can see that value. It for you to increase scattering region. If you don't want to select, you can take 0 also, but I'm selecting here like this, and you can see. And click the build tab. Use the simulator, add buffer if you want to add, and otherwise you can see in here the transistor tab. Click the transistor. Now you can provide in here the basic settings like gate value, IV curve, basic setting options, counter integral, electrode, iteration control, basic set, spin types. It's totally user defined value. If you want to select in here the region types, you can choose. permittivity 25. It is a default value that we have selected. The system already selected that value. You can choose in here the thickness value, so you can see the thickness. Gate voltage, what type of gate type we have selected, like top and bottom, front and back, and like you can select gate region, it is editable. Source, like left or right, biasing voltage, totally user defined value, like if you want to calculate for 0 0.4, 0.5, 0.6, 0 0.7, 0 0.8, 0 0.9. We have already provided that tutorial. If you want one, like this, please follow that steps. You can use that thickness and that value. K point samplings for the IV curve. Basic settings that we already seen in the simulator and analytical XCF files. Electron temperature, energy cutoff, RT read work and electron volt, exchange correlations, K point sampling, counter integral, electrode, iteration control, basic set, spin type, uh, gate is only showing front and back, not showing. You can use that tab, sir, top and bottom, front and back. That we have already and selected in here, and that regions we have selected. So please follow that step. So Simran ma'am is asking, kindly design the field effect transistor having channel region and subtract as a CSI. Ma'am, for the designing of the projects, we will send to the PDF also after the session. Because if you're jumping with another, so it will in the device studio, so using showing only front and back in the drop down list, sir. You can use that tabs, and if you have more correlated to this, we will connect to the after the session. I will explain how we can use. Gopal Krishnan, sir. Okay. And Simran ma'am, we are also connect to you and send the PDF files for the field effect transistor. IV का basic setting, that type of setting you want to select, you can use. If you want to spin types like collinear spin, general spins, you can use, but we are just only for the simple no spin tab, and then please click the generate file. You can see the device, left electrode XCF files and right electrode XCF files, and 0 no gate voltage, and for 0.2 at you can see that voltage we have selected, so that input files are showing in here. For the left you can check that setting you have provided, you can see in here. In the previous session we have already told if you are running the device, so first we need to run the left electrode, you can directly run left electrode, right electrode, and then device XCF file. We need to import in here the slump. Running status you can see, and after that we need to run the right electrode, then for device. Same for we run first XCF file one by one, then that file also, IV files, and you can also check their script. It is a editables, and if you want to change or edit, you can do in here. Number of atom is 77 in here. It will take time. Run one by one. First you need to run XCF and then IV. For that it is a transistor calculations, and for the PT or anything if they have, I will also provide the PDF file. In the basic setting you can see the doping, so if you do dopings or user define or anything, so different format of file you can create. It will take time. My one file are also running in that conditions, so they are also still running. So we have so after the completion of that project, I will show how you can see your results. Move toward the simulator tab, nano decal, and in here you can see the transistor plot. Click in here the transistor plots, and after that please upload your project directly in here. Select 1 minute, it taking time. Move toward the simulator, nano decal, and click the transistor plots. And simply you choose your project where they store. Like my project is stored in here, and device studio in your projects. In between they come again and again because the program are still running. So directly imports and use that transistor plot tab. So you can see in here your results with different voltage. I will also provide the PDF so you can read, and you can contact us after the session also. In here we are just created one of the device and then show how we can use the transistor options and create their IV voltage and related curve. So it's one of the examples that I'm showing in here. Many users are asking about the one of the PN junctions type of device or material. So I also going to show that one simple example of PN junctions. So after the this sessions, you can con contact us for this result.
Sir, how to get the transistor plot in this particular just last slide you have just saying the simulate go to the simulators
Go
and
to
then
the, it is not 1 minute, I will show. Simulator, nano decal, and transistor plot. And then where your project are stored, like my project is stored in here, home,
hmm.
and device studio, and it is again and coming there. I'm not able to show you. Hmm. As like your project is untitled 36,
Okay.
and like you can see your project are in here, and then please click in here, and you can see device, and when the results are coming here, select that folder, and then result will come after the completion. Like select in here results, and you can see if they are completed like VDA and another, they will show for the different respective voltage. Okay, sir.
Okay, okay, fine, sir.
Uh, if they are still running, please click the device studio at the mouse and open the second page for the device studio. Right click and then open again. Like you can create new projects and select and save like this. We are going to create in here one of the silicon PN junctions, simple structures. So please follow that step. Click the files and import local. You can select any materials, but I'm just selecting one of the semiconductors like silicon. You can import silicon. Again, you can move toward that different types, but first we need to redefine our crystals because it just selected only simple unit cells. But if you want to redefine, you can create and phase center types like this, and click the build. Please follow that step. Build. You can again click the build and redefine like this for the B direction, but C direction it totally depend on you. We are just selecting, but you need to consider the number of the atoms. If you're taking more number of atoms, so it will take much time. If you selected 2 atoms, so it will look like, you can just select like this. Sir is asking, please repeat. Okay, sir. First, you click the file option and import local. In the 3D materials, you can see the semiconductor. and silicon. Please import silicon, and then after this steps, move toward the build tab. It is a second step, redefine and click the face center like this, and you can check preview and then click the build tab. And then again move toward the build tab, redefine crystal, move towards the 3 at the C direction and check in here the preview. And click the build tab like this. Okay, sir? Okay. Then again move toward the device, left and right, and click the preview like this. Please click the device and then left and right and click the preview tab. If you want to change in here that value, you can change, but we are simple selecting the default value and you can choose. And then click the build tab, sir, like this. But you can see scattering regions are small, so if you want to increase the scattering regions, you can use nano decals and add buffer. Like you can choose that for 5.33. You need to select any other value like this if you want. Okay, ma'am, we are going to repeat again. You can, I hope you have created the device. If you have to redefine that form, and then please click the convert to device tab, left, right, and then preview, and then please click the build tab. And then click that device tab, and you can again move to the simulator, nano decal, and add buffer. It totally depends on you which type of value you want to select. Only for that direction, you can see the size of the increase can be given as the length of angstrom. It for only the size, and click that build tab like this. I hope everyone have completed these steps. After that, you need to select that silicon. Please select the silicon. And then move toward the simulator, nano decal, and virtual crystal approximation tab. Please select the silicon, simulator, nano decal, and virtual crystal approximation tab. In here you can see mixing vacancy and mixture atoms, both type of option available. P type and N types option available. If you want to change the value, you can change. So please silicon, simulator, nanodecal, virtual crystal approximation, and P type. You can see basis, and it also given the user defined option, and then click the generate files. Please follow that step. You can see one of that virtual crystal approximation .mat file are available in here. Now you need to again move toward the simulator, nanodecal, virtual crystal approximation. You need to select N type. Please follow that step, sir or ma'am, and then click the generate file.
So can we define crystal orientation also here? This is 101 or 11 like that.
Yes, sir, you can define simulator, nanodecal, virtual crystal approximation. In here you can give that value. It is editable value, sir. Okay, and in here you also see the option user define. If you want to import some things, you can also import. Okay, and second for the mixture atoms. In here that tab are also available for the compositions. You can add like this. Okay, sir.
Okay, okay, sir.
We have created for the P and N types virtual crystal approximations. After that, we need to import for the device. Simulator, nanodecal, XCF, basic settings that you have seen electron temperature, it will be same. We have already told about this. Counter integral, it is user defined. Electrode value, iteration control. You can see Hamiltonian density and different mixing variables. Some are given, and basic sets. If for the Howard terms, have we calculated for the transition elements. You can see in here the bottom side doping options. Click in here the doping option, and at the that tab you can see arrow look like and user defined, because we have created in here. Now we
Sir,
need to
doping is not showing.
1 minute. Simulator, nanodecal, XCF. You can see that doping tab for that basic set options are.
Yes, sir. I have basic set. Here it is showing only the atom level basis.
You're not showing only the doping option.
Yes, yes, sir. Not showing.
First, you need to select the device. You have
Okay,
selected
okay.
that
Okay. Sir, I have selected this device and
device
that.
tab,
Yes.
and you have created that virtual crystal approximation, sir.
Yes, sir. I have created.
So you need to contact us, sir. We are showing the device. Anybody have the issue? Same like doping. You can zoom like you can do like this if
Okay, sir, I'm checking.
okay, you can check again. And
Not showing, sir.
I'm Sir Muswarin sir asking I'm unable to create virtual crystal approximations. Sir, you need to move toward the simulator tab, nano decal. First you need to select the silicon that we have imported first time and nano decal, and then you can see that tab, sir. Virtual crystal approximation. Muswarin sir, please check that. Select silicon.
Sir, files are not generated, sir. I have been working since 5 minutes, but files are not being generated.
Ma'am, you can try again. Please close the
I've
device
been trying
studio.
since 5 minutes, sir, but it's not working. I'm not able to create the files. Generated files are not seen here.
If you are not find that file, so you need to connect after the session, ma'am. I will contact
Okay,
you and how we can solve that your issue, ma'am.
okay, sir.
Because we can you can see in that tab simple
Okay.
silicon, and then you can try one more time. Please close your device studio and open with existing project, and then you can again try.
Okay, sir. I
Maybe it
will
will
try.
work. Okay. And sir, you can use that virtual crystal approximation tab and you can click the generator. You need to wait some time. They will generate first p types, and after that p type file created, then you need to select n type, and then you create again generate files. And anybody that have issue related, so they are not showing, so they can contact after the session. They will message us, and my colleague will contact today individually if they have issue. Simulator, nano decal, and XCF, and you can see here the doping. You can see that user define option. Now you can see it is a project 37. That type of project you have saved. You need to search your projects where your project are stored.
बिंदी खींच को हाँ रखो पकड़म जरा सा ना आए
Please,
जरा पकड़म वर्कशॉप सुनते हैं मैं बाद
please,
में रख लेती मैं जरा पकड़ को रख डालो अम्मा
please, ma'am, mute yourself. Like project 37, you can see silicon, nanodecal crystal. You can see your files. First, for the P type, you need to select that files, open. Search. If you want to select that P types, like you can count your atoms. It totally depend on you. And then click the select. Please follow that. You can select at like 5 if you want. Click your mouse and hold and then select. And then click the OK option. Abraham completed this step. And then click the OK. Now you again move toward that plus tabs. You need to add for the end type also. User define. Go to your same project folder. And select that file. Search. And select that another portion for the end types. And click the select tab. Please follow that step. And otherwise you left out in this part. And then click the OK. And after that, you need to click that generate files. If you want to set another parameter, you can set, and otherwise you can simply click generate files. You can see your XCF input file have generated. Open. Now you can see your VCF files for PNG type. They have come, and your return block you can check. That type of settings you have provided, you can see. And if you want to change any setting, you can change it. Is editables like this, and you can use that save tab. So first you need to run XCF for the left electrode. You can directly run. Run your files. Same for the run for right electrode. And then run for that. If you want to move analysis parts, you can move toward the analysis part. You can choose any value. So we are just showing in here that VCR PN junction types. Number of user asking about this. We have a lot of the materials, so we also provide the things. And we have that projects, we have stores. 1 minute I will show. You can move. We have that type of VCF files that we have created, and you can see some of the results. It for that type of structures we have in the previous time we have created. like this, choose that type of structure and then redefine it. At the same, we can create the buffers like this, and then imported that silicon VCA virtual crystal approximation files one by one. You can check that XCF files like this. And after that, in here we have also done some of the analysis. It will take some time, therefore I'm just showing the previous examples. Like you can see, if you want to export imports, we have already told. For the 3D, you can see 2D. It's for just no spin. 1D, you can export for Y and Z. It totally depends on you which type of settings, which type of parameter you want to done in here, you can do. And that file will open in the MATLAB also. So some files that open MATLAB, you can directly import your project in the MATLAB. Coulomb potential, density of states. Like you can see. You can see the photocurrent. We have not chosen any value or anything. You can see the photocurrent tab, nano decay, analysis. AC condensance, thermoconductor, photocurrent types. You can see for the X, Y, or Z axis, for X like, and for Z polarizations, that type of set. It user defined data. So here you want to give the lights or anything and select, then uses that type for the photocurrents. We are also working on this. So it is some of the example portion that we have shown. We have a lot of the video and some of the papers and tutorials that we also provide in the after the sessions. And you can also check Nano Academic Technology, our parent company. We have that papers. You can check in the Google Scholar for the nano decays, like you can see. How you can search. Like you can see, some paper are also present, so you can study and you can collect your data from here. We have the YouTube channel also. I hope you have already checked. Impulse Technology. Some of the video we have 2 sessions that we have provided. We will also upload another video. You can see QT project and SetFOS for the solar cells and device studio. And here you can check rescue softwares tutorial and nano decade. So you can check that tutorial. We have a lot of the tutorials, training programs and things are available in here. So please check. We have that KiTiCat projects and SetFOS large softwares. So we have different softwares are also present. We will explain in about these software in the tomorrow sessions. So you please join this tomorrow session so you can also get a lot of the idea about Impulse technology and their softwares. Simran Patra ma'am is asking, we are very blessed over the last 4 days for live interaction session. Thank you, ma'am. And we will also help the FAT structures. So we will contact you. And otherwise, we have that number. So you can please message and we will definitely contact you. And please ask if anybody have query related to this and device structures or PN junctions, transistors like this. Please ask. It is open to all. It is still running. Please ask any query. Uh, Subrat Kumar sir asking how we can plot the graph. In the simulator tab, if they created that type of files and results, in transistor plot that option are available. Select folders and directly you can jump through the like this. They are completed so you can get transistor plots. Sir. Gopal Krishnan sir asking in PN junction diode transistor how to check the depletion region. When you have created the PN junctions, so atom selection ports are available. So you can check in here and otherwise you can also see in the MATLAB where the data is available. So that two regions are available. How we can calculate the band gap through it? It will very simple. You can select the simple AG, and you can move toward the build tab. Sorry, I'm calculate the band gap through. First, you need to find that band graph from this tab. You can also redefine, otherwise you can simple move toward the simulator, nanodecal, XCF files you can generate, and then you can move toward the simulator, nanodecal, and analysis. In here you can see the band structures. And after that, first you run to XCF files, and then band structures, and their data is available on the MATLAB. For the graph, you can see in here, graph is available in here, but if you want to band gap and their data, so you can directly use the MATLAB tab. For the data, you can see in the MATLAB. But graph, if you want to see, you can check in here. So I hope everyone have completed their query and that type of projects. So please join the tomorrow sessions. I am very thankful to all of the participants who joined this session. Now I'm going to end here that session. Thank you very much.